We'll continue with another example of the 3D polar. So here they tell you you're integrating dv, and it's the region above this and inside this. Anytime you see x squared, y squared, and z squared, right away it means that you're integrating 3D polar. So you go, it's dv, which is this, radius, I told you, in this case, this number is p, so your p squared is 2, making p root 2. So we're going to go from 0 to root 2. Complete circle. It's angle to the problem. They tell you inside of this and above the cone, it's a little bit complicated. I'll tell you the trick. It doesn't work for all of them, so hopefully it doesn't make it so hard. Apply this concept. So it's cosine inverse 1 over p, so it would be cosine inverse 1 over root 2, and that's pi over 4. So you're going to go from 0 to pi over 4. Now you're integrating p, so it becomes p3 over 3 sine and you're going to put 0 on root 2. Put the root 2. Root 2 cubed would be 2 root 2 over 3 sine angle, and the 0 cancels out. So I'm going to erase some of this. I know that I'm integrating this d phi d theta. So 2 root 2 over 3 sine phi d theta, and 0 pi over 4, 0 to pi. Integrating sine would be negative cosine. We need pi over 4 and 0, and then do the d theta. Cosine pi over 4 is 1 over root 2, so you have this 1 over root 2 minus, you put the 0, it would be 2 root 2 over 3, and cosine 0 is 1. Cancelled, so basically you have over 3 minus 2 plus 2 root 2. Now that's the constant that you're integrating from 0 to 2 pi. Minus 2 root 2 over 3 d theta, integral would be this theta and 2 pi 0. So 2 root 2 over 3 times 2 pi minus 0, so you just leave it as is. So we did the polar 2D and we also did the polar 3D. Now you're going to do integral involving what's called line segment. So for example, x squared z, and you're going to see ds. So make sure you see a ds, and it's the line segment joining 0, 6, minus 1, 2, 8, 0. So here you're doing the line segment ds, but remember, no curve given. So you need to find the curve yourself. So you say, okay, let me think. If I plug 0, I get 0. And if I plug 1, I get 2. So it's 2t. So plug 0, you get 0. Plug 1, you get 2. If I plug 0, I get 6. If I plug 1, I get 8. So it'd be like 2t plus 6. Plug 0, 6. Plug 1, 8. Here, if I plug 0, I get minus 1. So it must be something like t minus 1. You plug 0, you get minus 1. You plug 1, you get 0. So I made the curve. Once you made the curve, you can find ds. ds, you find the derivative of this, which is 2, 2, 1. And ds will be the magnitude of this. 2 squared, 2 squared, 1 squared, 4, 4, and 1, that's 9. Square root of 9 is 3. So again, when they tell you to integrate ds line segment joining 2 points, remember, if there is no curve given, you have to come up with the curve. We found the curve, we found the derivative, and we know what ds is. So now I'm going to erase some of this. I'll leave it. So now we integrate. Instead of x squared, I put, this is my x, so I go 2t squared. Instead of z, I put my z, t minus 1. I know I'm going from 0 to 1. Instead of ds, I put 3. I can put it outside. And everything is in dt. So 3 outside, integration 0, 1, 4t squared times t, so 4t cubed, and 4t squared minus 4t squared dt. So 3, integrating this is t4, integrating this is 4 over 3t cubed, and it's 1 and 0. 1 gives you 1 minus 4 over 3, and 0 gives you 0. 3 over 3 minus 4 over 3 minus 1/3, so the answer is minus 1. So this is how to do the line segment when you're joining 2 points, but no curve given. So we'll do another one, but now curve is given, which is the next one. So this question, evaluate x plus y, you see ds, and they give you the curve. They tell you it's 2t, t squared, t cubed over 3. So right away I need to find the derivative, which is 2t, and t squared. Okay, so we found the derivative. And from the derivative, I can figure out my ds. ds would be the magnitude. So the 2 squared, 2t squared, and t squared squared. This is 4t squared, t4. This here is a complete square. you square root the first one, you square root the last one, and if you think about it, if you expand, you get this. So basically, this is the square root of something squared, so your ds would be 2 plus t squared. So that's your ds. So you integrate now. They tell you x plus y, 2t, t squared, ds, 2 plus t squared, everything in dt. And they tell you in the question, and I wrote it on the side, they told you in the question that you're going from 0, 0, 0 to the point 2 1/3. Obviously 0, 0, 0 we get if you plug 0, and 2 1/3 we get when you plug 1. So I know that I'm going to be going from 0 to 1. We expand first. This time this is 4t. This time this is 2t cubed. This time this is 2t squared. And this time this is t4 dt. Integral. First one, 2t squared. This one is 4 over 4. This one is 3 over 3. 5 over 5, and you plug 0 and 1. Plug 1 gives you 2. 1 here gives you 2 over 4, which is half. 1 here gives you 2/3. And 1 here gives you 1 over 5. And 0 gives you 0. So you can do this in the calculator and see what the answer is. Okay, so we did the line segment, no curve given, and we did the line segment with a curve given. There is a line segment question when ds is not given. It's not in terms of ds. I'll show you. So integrate the curve, the f vector line segment from point 0, 0, 0 to point 1 minus 1, 2. And they give you the f. They tell you it's x squared, x minus z, xz, and then they tell you, well, where is it? Basically, you're integrating x squared y dx, x minus z dy, and last one dz. That's what they're telling you. So again, you ask yourself, no curve given. Remember, no curve given, and it's not ds. So no curve given, we make the curve. If you plug 0, you get 0. If you plug 1, you get 1. So the first one must be t. You plug 0, you get 0. You plug 0, you get minus 1. It must be minus t. You plug 0, you get 0. You plug 1, you get 2t. You get 2, so it must be 2t. I find the derivative. That's dt. That's minus dt. That's 2 dt. This would be equivalent to dx. This would be equivalent to dy, and this would be equivalent to dz. If ds was given, you would find the magnitude. Here we don't, so we just integrate. X squared, this squared, times y, which is minus t, and dx, which is dt, plus x, which is t, minus z, minus 2t, dy, which is minus dt, plus x, which is t, z, which is 2t, dz, which is 2dt. And we know that it's going to go from 0 to 1 because 0 gives us this and 1 gives us this. If you write this in a better way, watch. This is minus t cubed that we're integrating. Here it would be minus t times a minus, so it's like a t dt that we're integrating. This would be 4t squared that we're integrating. Integral of the first one is 4 over 4. For this one, squared over squared. This one is 3 over 3, and you put 0 on 1. So it would be minus 1/4 half 4 over 3 minus 0. If you combine them all, or you do this in the calculator, this is 19 over 12. That would be the answer for this one. Okay, so we erase this. So the question here is show if it's conservative and find possible function. Show if the function conservative and find possible function. Alright. So the function is given 2xy, y sine of xy, all of this in the I direction. And you have x squared, x sine xy, plus 6y, all in the j direction. So to test for conservative, we call this m, we call this n. We find the derivative of this with respect to x. A constant x is just a constant. Derivative of this, y is a constant. Derivative of this would be cosine times the derivative of the inside. Oh, I made the mistake, sorry. We need to switch. So usually this one is the x, this one is the y. But when we test for conservative, we found my and nx. Testing, you need to switch the derivative. Derivative with respect to y, a constant y is a constant. Here, we have to do product rule. Derivative of the first one is 1 times the second function. Derivative of the second function would be cosine times the inside. Derivative of the inside with respect to y is x times the first one would be xy. So we need to find the derivative for this now in the opposite direction with respect to x. Derivative of this is 2x. Derivative of this with respect to x, again product rule. Derivative of the first one is 1. So times the second one. Derivative of the second one times the derivative of the inside y times the second one xy. And 6y, derivative of 6y with respect to x is 0. So my equals nx, yes, is conservative. So yes, we know now that it is in fact conservative. So once you know that this curve is conservative, we can find a possible function. This is how you find a possible function. It's only x and y, so you go possible function. I'm gonna integrate m, but now dx. So not like we did for the conservative, we switch. No, we just do mx, the normal way. Integrating this with respect to x would be x squared y. Integrating this would be minus cosine xy over the constant y, but it cancels with the other y, plus a g function in terms of the other variable, which is y, plus a constant. I call it c1. And you also say, I'm going to integrate n dy. A constant would be a constant y. Integrating this would be minus cosine xy over the constant x that cancels with the other x. Integrating this is 3y squared plus another function, I'll call it k, in terms of the other variable, plus a constant c2. So possible function anything repeated, you include once. So x squared y, we're going to include once. The cosine, we're going to include once. But there is 3y squared new, so we add 3y squared. And then everything like the g, the constant g, we combine them all into a big constant. This here is your function. There is another one for finding the conservative, but it's 3D. So involving x, y, and z. But I'm going to stop this, and that will be in the next part.